Hey guys, let's talk about section 5.1, which is on quadratic functions. A quadratic function has the form shown here. F of x is ax squared plus bx plus c. The sort of giveaway is that you've got x squared as your highest power of x. And the reason we say a can't be 0 is because if a were 0 and this term weren't here, then it's no longer a quadratic function. Then it would just be a linear function. So let's look at graphs. Now, the information here below is probably stuff you've seen before, but I want to kind of run through it a bit and then play with it a bit on Desmos. The sign of A determines whether the parabola opens up or down, and the solutions tell you where it crosses the axis. And you can find them by sometimes factoring, or you can always use a quadratic formula. And this part of the quadratic formula under the radical tells you how many x-intercepts you have. If it's positive, you have 2 x-intercepts, and that's because you wind up getting a number under here. You get one for the plus and one for the minus. If it's 0, then this whole thing is 0, and adding or subtracting gives you the same thing. And if it's negative, you get no solutions or no roots because it winds up giving you an imaginary number. So let's take a minute and just play with this. I like to play with functions. It's like they're toys. Let's see. I meant to move Desmos up. Let's look at this. Suppose we have f of x equals ax squared plus bx plus c. And there it is. It's a parabola. If I move this to make my b and c both 0, then we get the function y equals x squared, which is the parabola we always think of. Now, if you look at this, the c is going to make things move up, make it move up and down. B in this case is going to move it like that. But a is the thing that determines whether it opens up or down. If a is positive, it opens upward. And if a is negative, it opens downward. So it's kind of fun just to play around with this. Tell you what, let's do. I'm going to put in a formula here for the discriminant. Let's see, b squared minus 4ac. And it gives it to me right there, 7.84 for this particular parabola. If I start moving my c around, if I bring it down here, notice down here we have no solutions. There's nowhere where the graph crosses the x-axis. And in that case, our discriminant's negative. If I move it up here where it crosses in 2 places, the discriminant is positive. And let's see, I don't know if I can get it to stop exactly on here. But if I could get it to stop exactly on the x-axis and just have a single solution there, it would be 0. I should be able to do that if I adjust my b. I'm going to make b equals 0. And if I move this up to here, note right when it touches the axis, here we only have one place where we only have one x-intercept, and the discriminant's 0 there. And this works the same if I make my a positive. Up here, the discriminant's 0. If I move this down, if I move it up, the discriminant's negative now because there are no places where it crosses the x-axis. And if I drop down here, it becomes positive. So let's do an example. Find the x-intercepts and the vertex of this quadratic function. All right, the vertex, well, I haven't said how to find the vertex yet. Let's find the x-intercepts, and from there we'll find the vertex. Now, the x-intercepts, that's where it crosses the axis. So I'm going to set this equal to 0. Let me change my pencil for that. 2x squared minus 4x minus 6 equals 0. Now I've got to factor this. First thing I notice is I can divide by 2. So divide everything on both sides by 2. And I get this. And now, let's see, x 3 and 1, and I'm going to make the 3 negative and the 1 positive. That way they add up to -2 and multiply out to -3. So that gives me solutions of x equals -1 and x equals +3. Those are my intercepts. My x-intercepts. Now, I also said find the vertex. Now, it's already showing up down here, finding the vertex. But let's say we didn't know how to find the vertex. We've got a nice little formula down here, but pretend we don't know it yet. How can we find the vertex? Well, if you were to graph this equation, and let's look at a couple of things. We know that it crosses the axis. I'm going to do this by hand, and then we'll probably look at it on the computer as well. Let's see. At +3, it crosses the axis. At -1, it crosses the axis. And let's see. A is positive. So that means it opens up. So that means if I were to draw this in, my parabola, now I don't necessarily know that I got it to the right height. Maybe it's supposed to come further down here. Maybe it's supposed to be a wider parabola. But I know that it looks roughly like this. And here's the cool thing. If it crosses the axis here and it crosses the axis here, then halfway in between is going to be where it has its vertex, just by symmetry. So let's work this out. This is at -1, 0, 1, 2, 3. So if I go across here, that's a length of 1, 2, 3, 4. So that means my vertex is going to be here at 1. How do I know at 1? Because you draw that looking straight on at it. Because the distance from here over to here is 4. So half that distance is 2. So this is going to happen at the x-coordinate of the vertex is 1. And the y-coordinate of the vertex, to get that, we just do f of 1. And so f of 1 is going to be 2 times 1 squared minus 4 times 1 minus 6. What is that? 2 minus 4 minus 6. 2 minus 10 is -8. So my vertex here is the point 1, -8. And I did that by just knowing a little bit about the graph. I guess really the only information I needed was that it opens upward and we had these x-intercepts. Now let's check this on Desmos. If I graph, I'm going to delete all this stuff. Just put in y equals 2x squared minus 4x minus 6. We get this. Sure enough, there's a intercept there at -1, 0. Another intercept over at 3, 0. And my vertex down here is 1, -8. So if you think about what we did here, to find the vertex, to find this x-coordinate, what we did was we found what was halfway in between these two x-intercepts. Another way of thinking of that is we took the average of the x-intercepts. The x-intercepts are given to you by the quadratic formula up here. So let's look at the two solutions there. The x-intercepts are minus b plus the square root of b squared minus 4ac over 2a and x is minus b minus the square root of b squared minus 4ac over 2a. And let me switch so you can actually see what I'm writing. All right, so those are my x-intercepts. If we take the average of these two guys, I'm going to just go back and do this. To take their average, I'm just going to take these two, add them together, and then divide by 2. Now instead of dividing by 2, I'm going to multiply by a half because I don't have a ton of space left on this. So if I add these up, I get 1/2. Now inside my parentheses, the denominator is 2a. And so I've got minus b plus my discriminant. Then over here I've got plus b, or well, plus negative b, and then minus the discriminant. So cool stuff happens. These two guys cancel, and I'm left with 1/2 negative 2b over 2a. And I can cancel these 2's, and I'm left with minus b over 2a. So that's a derivation for finding the x-coordinate of the vertex. Now what I would recommend is just memorize this. It's going to come up often enough that it's good to know. So just memorize that the x-coordinate of a vertex of a parabola is minus b over 2a. Let's do a quick example. Find the vertex of this parabola. All right, the x-coordinate of the vertex is minus b over 2a. If I come back up here, a is 1/4, b is 3, and c is negative 4. So my x-coordinate is going to be minus 3 over 2 times a, 1/4. So I get minus 3 over, let's see, 2 times a fourth is a half. So negative 3 divided by a half is negative 6. And then to get my y-coordinate, I just plug that in for x. Plug in the 6 for x. 1/4 negative 6 squared plus 3 times negative 6 minus 4. Now 6 squared is 36. Gives me 9. I'm just going to put this in my calculator. 1/4 times 36 minus 6 times 3 is 18 minus 4 gives me negative 13. So it's fine if you leave your answer like this. Or you could write it as an ordered pair. The vertex is negative 6, negative 13. And like always, I want to double check my answer. So let's throw it into Desmos real quick. All right, so my parabola is y equals 1/4 x. Wait, y equals 1/4 x squared plus 3x minus 4. So I get that, and if I zoom out and come over here and look at my vertex, sure enough, it's negative 6, negative 13. So any other problem where you're trying to find the vertex, you do the same thing. Use the formula to find the x-coordinate and then plug it in to get the y-coordinate. All right, we'll stop here for this video.